This morning we heard a talk by David Rose from MIT, and he brought up the topic of distributed computing, which has been, I think, an interesting trend and an important trend in how computing is affecting society, that we have processors and distributed devices as opposed to concentrated only in a personal computer. So you can have, for example, your cell phone is one of the best examples of distributed computing. To have, for example, a more intelligent refrigerator that knows the quantity of objects you have inside, and so on and so forth. So distributed computing is this idea of putting processors in everything. But what he didn't address, and what is a topic on my mind as a technology developer and also an electronic artist, is the environmental impact of distributing processing, because when you have processors in many different objects, you have to manufacture those processors as well as the battery supply that goes along with them. And my concern is that as interesting as it is, the behaviors that you can engender, the functionality that you can introduce with distributed processing and toys and cars and everyday household objects and so forth, it begs the question, is this really actually, in the end, these new features and functionalities, are they actually a benefit to society given the environmental impact that their production, distribution, and disposal has on society?
And you were saying earlier on that an example you would also cite would be one of the hybrid cars.
Okay, well, let me first give the heating system example, because I think that actually illustrates the point very well, which was you asked me what about, for example, an intelligent home that was able to know when I was there, or for example, when I'm leaving the office, so it can turn the heat up when I'm coming home and turn it down when I'm leaving in the morning and so forth, which is, it's an excellent idea for potentially increasing the energy efficiency of a home, but you have to look very carefully at the production costs, the environmental and energy production costs of introducing that system. How many processors and battery and additional supply do you need to run that, not only in the house, but also wherever I happen to be located, and transferring that information wirelessly? If the cost of running the control system exceeds the actual energy savings, the direct energy savings from the heating system itself. I also mentioned the point of these new energy efficient cars. So for example, the Toyota Prius, which sounds like a wonderful idea to buy an electric car, but again, you have to look at the production costs from an environmental standpoint to produce that car in the first place, because the factory will release carbon dioxide into the atmosphere. You're removing metals from the earth. You require a lot of oil, petroleum, to make the plastic products. You release a lot of wastewater. And so on and so forth. And then there's the energy costs of keeping the factory open, and the people driving to and from the factory, and it just goes on and on. So I think that we need to look a little bit more broadly, not only about the direct sort of product claims that a Toyota Prius gets much better gas mileage, which is wonderful, but you have to look at, how much does it take to make a Toyota Prius? And what about all the cars that we already have in the world that are perfectly serviceable and with, a tune-up could be kept on the road? Is it really in our best interest to wipe out what we already have, replace it with something that on paper has better energy efficiency, but yet promotes this kind of, in my view, unsustainable consumer culture? So we need to move in the right direction. The same thing is true for solar panels, wind power. All of these are great ideas, windmills, for example, but how much energy does it take to produce a windmill relative to the amount of energy benefit that we get from that? So putting into place a sustainable energy policy is not only about looking at the features or the direct energy savings that technology offers to us, but how we produce them, how we roll out the acceptance, and also how we maintain what we already have to make the most of existing technologies that are perfectly functional, maybe not as good in their specification as what we can produce, but nevertheless, they already exist. We don't have to throw them away. And again, it may be a more enlightened and ultimately energy efficient way to move into the future.
If you go to the supplementary question that we're asking everybody at Lyft this year, what would you do if you were given the sum of money that Lyft is spending on its carbon footprint here?
Well, again, my first response to your question was, how are you calculating that sum? You initially gave me a sum of 1,000 Swiss francs, and I seriously doubt that is in fact the actual carbon footprint, considering that people have flown in from Korea, the United States, all over Europe. You have to look at the carbon impact of their travel. You have to look at the carbon impact of all of these disposable coffee cups and water bottles that we're throwing away, and then of course the obvious, the heating and so forth, the lighting in the facilities, running the projectors. So I would actually be interested to know what really is the total amount. If it's 1,000 Swiss francs, I would certainly argue that meetings such as Lyft are well worth the expenditure, because you bring together people who can have enlightened conversations about how we can create a better society, and that's important. Sometimes you have to spend in order to save later. But if it exceeds, how do you estimate the economic value of bringing people together? That's an interesting question, particularly when you ask with respect to saving energy. So I'm not answering your question, but I would say that perhaps in a future Lyft conference, it would be nice to challenge the participants, first of all, to enlighten them on their carbon footprint. So I would let them know, I would give them a metric by which they can calculate their impact. I would recommend that you look at, for example, Watt On. It's developed by Saul Griffith. He spoke about that at the TED conference this year. So, for example, give all of the participants in these conferences a tool by which they can calculate their carbon impact as a consequence of attending, and challenge them to return that, if not more, value to their society as a consequence of their participation. Because if they cannot do that, then I think there's a good argument to be made that we have no business flying around the planet for the purpose of meetings like Lyft. If we cannot give that value back to society, of course energy savings aren't the only value, but nevertheless, I mean, we are entering, I think in the next several decades, a period in which the impact of our consumption and our energy use in terms of air pollution and water pollution and the increased cost of limited resources will become a major factor in how we evaluate what something is worth.
Kelly Heaton, thank you very much.
You're welcome. Thank you.